Alright, ready? We want to set this equal to 0. We want to solve for zeros, right?
Really?
Now when we do quadratic formula, it automatically sets it to 0. But I don't need to set this for a quadratic formula. Okay? I can solve this. Waylon,
shut up.
Okay. Alright. So, we're going to move this. Right? And always do the opposite. Plus 3, plus 3. 7x squared equals 3. Now am I going to get x alone?
Did you,
Divided by
7.
7. Okay? So I get x squared is equal to 3 over 7. How do I get rid of the square?
Times 2 times divide.
Opposite, right? What's the opposite of square?
What is the opposite of
Square root. What do I do to one side? Gotta do the other. So here's the problem. We can't have the square root of 7 in the bottom. So I got to get rid of that. Okay? But it's not that hard. If I multiply it by itself, right? What's the square root of 49? 7. Right? So when I do to the bottom, I do to the top, and I get, what's 3 times 7?
A number.
21.
And the square root of 49? 7. And that's, I didn't have to use a quadratic formula for that. So, again, what I'm telling you is, if you don't need it, don't use it. Okay?
Yeah.
Alright. Is this thing recording?
Yeah. Is it recording?
Check this out. This is your product, right? Your product is 1. Actually, your product is positive 1. Because these two are negative. Okay? And that's going to be huge. That actually makes a difference here. Okay? Now, your sum is 1. And we are actually adding to be the sum. We are, because this is making this become an addition part. Okay? 2 negatives make a positive. Okay? So we're adding to get 1. Okay? So what multiplies to be 1, but adds to be 1? 1 plus 1 is
2.
Oh, that doesn't work. Right? Nothing, right?
Nothing.
That's the point. It's not factorable.
So what do we do?
That's the point. Quadratic formula. This is where quadratic formula... See, some people teach it, I used to teach it as, hey, all I'm going to teach you is quadratic formula because it always works.
It always works.
Always works.
So let's do that.
But sometimes it's easier just to throw in, I can factor this, right? I can factor this. I'm done. So then I started thinking, okay, don't be such a smart angle side, right? Because I'm always like, oh, I'm better than the book. I'm better than these teachers. I'm better than, because, you know, I always want to think I'm the best, right?
You are the best.
Because I am. But you know, as I got older, I started to realize that, okay, there's some reasons why we do some things. Okay? Quadratic formula does always work. But it's a big formula, and it's a lot of problem. Okay? It's a long problem. So, sometimes you don't need it. Okay? But in this case, you do. So let's write down what the quadratic formula is. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Whereas ax squared plus bx plus c is the quadratic. Okay? And you guys remember me talking about that 2ax plus b, right? Because that's how we found the axis of symmetry, right? So we've done this, part of it. Okay? So now, what we want to do is try to figure out the quadratic formula from this. And when you do the quadratic formula, have it set up right here. Right, Waylon? Right here. But, because, Waylon's got dope-ass rhymes memorized. Right? And you can get these rhymes memorized too. That's what I noticed with kids who can just, they can sing lots and lots and lots and lots and lots of music. They're really actually hella bright. Most of those kids don't do crap in school, right? They'll be walking through the hallway, doing nothing. Waylon's not one of them. He's been killing it this year. I'm just saying, I see a lot of those kids not doing stuff. And then when I chat with them, they come in the classroom and they start just killing it. And they're like, I didn't even know I could do all this. I'm like, I knew. I knew, because if you can memorize 1,000 different verses from 100,000 different songs, right? How can you not memorize a couple equations? You can. Okay? Alright. But even if you don't have this memorized, it's on your, they give it to you on the SVAC. It's on the first page. Okay? You just got to know how to plug it in. Okay? Waylon, no bit. Settle down. Okay. Alright. Let's go through this. This is A. This is B. This is C. This is A. This is B. This is C. Okay? When I plug this in, okay? When I plug this in, I read this and I go negative B. Look at that. Did I write B? I didn't write B. I said B. I said B, but I don't write it. I write the parentheses. Every letter, I put a parentheses. Negative B, plus or minus, the square root of B squared minus 4 AC. Now kids, they don't listen to me. They don't put in these parentheses. You need to put in the parentheses. Okay? They're huge. They are what lets you know what's going on. Without them, you will make mistakes. With them, you're going to make mistakes. Without them, you'll make more. Okay? All over. All of it over. This is another big mistake. A lot of students just go underneath this, and then they get confused where this goes. No. All over. All of it. Over 2A. Notice I only have a couple of letters or numbers written here. Okay? Now I'm going to start plugging in. What's B?
Oh. No.
Minus. Good. Minus what?
1.
Perfect. So, there's a minus there. We're like, minus what? Minus 1. Okay? So it's going to be minus 1. That's your B. What's A? What's A? Minus 1. And what's C? Oops, sorry about that. I should have circled that whole thing. Notice how I did not circle the X's. I only circled the numbers. Okay? So, C is also minus 1, right? All right, here we go. What is a negative and a negative?
Positive.
So positive 1, plus or minus the square root. What's negative 1 squared?
What?
What's negative 1 times negative 1? Positive 1. What's a negative times a negative times a negative? Negative. Good. What's 4 times 1 times 1?
4.
Good. What's 2 times negative 1?
-2.
Good. All right. What's 1 minus 4? One minus 4. -3. All right, here we go. We have a -3. We're going to break this down. What comes out? You guys don't know this yet. I. I.
Oh, I.
Whenever you have a negative inside of a radical, I is equal to the square root of -1. It's what we call an imaginary number. Okay? What's left is 3, right? So I took out the negative. And I can take out a 3, and only a 1's left. Now, here's the weird thing. Remember I say circle your pairs? I is automatically a pair. I always comes out. Does that make sense? 2 I's, now that's another story. That's -1 times -1, which is a positive 1, which is, yeah, still 1. So I squared is really 1. But I is the square root of 1. Okay? -1. So what happens here is you have 1 plus or minus I square root 3 all over -2. And that's your answer. Okay? How are we doing on time? This thing's still recording?
About 16 minutes.
All right. Here we go. Let's do a little easier one. Hopefully this one won't be imaginary. Now, you guys are looking at me going, what the heck is I and it's imaginary and I don't understand it, because what's the square root of -4? What is the square root of -4? Well, what's the square root of 4?
2.
2. So this is 2I. That's all it is. Okay? It's imaginary. Think of the word imaginary. It starts with the letter I, right? Think of this. Is this frowning? Or is this smiling?
It's frowning.
Frowning. What happens is when we graph that guy, it looks like this. What happens when it's imaginary is that it's giving you the imaginary shadow of where these guys cross. Because the actual one doesn't cross. That's all this is. That's all the I means, is that it doesn't cross the x-axis. The shadow does, the imaginary shadow, but not the actual function. All right, let's do this guy. First of all, what's 2 times 3? Or 2 times 13? 26, right? That's your product. This is your sum. Is there 2 things that multiply to be 26 and subtract to be 7? Think about it. You got 1 and 26, you got 2 and 13, and that's pretty much it, right? So does either of those subtract to be 7? No. So this is not factorable. Right, Waylon? Waylon. I know.
What?
You gotta pay attention.
I am on right now.
I know, I got you. Alright. Next. Okay? What I want, what I really want, is to be able to plug this in. A, B, and C. So, negative B plus or minus the square root of B squared minus 4A, AC all over 2A. Alright, what's B? Skylar? What's B? What's B, Waylon?
7.
Yeah.
What's B? What do you pay attention?
What's A, Cody?
What? 2x.
2. Not X. Okay, good. Finally, somebody came up with the 2X. Alright. This happens all the time. Okay? Be careful. B
Don't be a Cody.
and A do not involve the X. They're just the numbers on. It does involve the sign, but not the X. Okay? Annie, what's C? Good. I thought I was going to trick you. Negative 13. It does include the sign. Right? Alright. So what is negative 7? This is a trick question. Ryan, what's negative 7?
Positive 7. Wait, no. Just negative 7.
Perfect. That's what I'm looking for. Just negative 7. Alright. Millennia, what's 7 squared?
Isn't it 49?
Yep. Alright. Hey, Jesus, what's negative times a negative?
Positive.
Boom. Alright, COC, what's 4 times 2?
6.
Close, that's adding it.
Oh,
Times.
times. 8.
Yep. Alright, 8 times 13. No, not that. Think of it as 8 times 10. 8 times 10 is 80. And 8 times 3 is 24. And what's 80 and 24?
Wait, what?
80 and 24, is that what you said?
Yeah.
That's 104.
Boom.
What's that kitty go make it hurt?
Okay. You see how that works? 8 times 10, right? 80. And then 8 times 3 is 24. I can do those two things really easy in my head. You can check it on the calculator. It's fine. Nothing wrong with the calculator. But you can do it in your head. All right. And 2 times 2. Boom. All right. So now, what is 49 and 104?
153.
All right. Now here's where it's getting interesting. How do I break up 153?
Upside down division.
Upside down division. So 153. I'm going to break that down. Is it even?
No.
No. So 2 won't go into it. Remember, 2, 3, 5, 7, 11. Those are your numbers.
Primes.
Right? Those are your primes. Does 3 go into it?
Yeah.
Why?
3 times 5, 15, and then 3.
If you take a look, what's 1 plus 5?
6.
What's 6 plus 3?
9.
Is 9 divisible by 3?
Yeah.
Then 153 is.
Yeah.
You can add the numbers, and if that number is divisible by 3, then that number is divisible by 3. Every time. So yeah, 3 goes into it. Like he said, 3 goes into 15 5 times. 3 goes into 3 once. Is 51 divisible by 3? Yeah, because what's 5 plus 1?
6.
Is 6 divisible by 3?
Yeah.
Then 51 is. Alright? How many times 3 goes into 5? Once with 2 left over, right?
Yeah.
21? 7 times. Does 3 go into 17? Does 7? Does 5? Does 11? Does 13? Does 17? Right? Alright. Now this is where it comes up. You circle your pairs. Whatever's a pair, you're going to bring 1 out.
Just 1.
Whatever's not paired
Just 1.
stays in. And now you got negative 7 plus or minus 3 square roots of 17 all over 4. And that's your answer. Please, yeah. Okay.